So hi, I'm Elsa. I'm from King. I work in the Central Marketing Analytics team, doing various types of reporting to marketing stakeholders, et cetera, what uplift is my marketing generating type of questions. I'm here to talk to you about the nested econometric modeling tool that we built to optimize and make our econometrics modeling a little bit faster. This presentation is going to kind of cover why we made our decisions when we were building the tool, what kind of tech we decided to use, and how it solved this business problem, rather than how did we automate an algorithm to make it predict on its own types of questions. Before I start with the tool, a little bit more about me and how I got into this, because it's a really complicated and unorthodox story. So basically, in 2010, I finished my bachelor's degree in communication and media studies because I had this illusion that I wanted to become a journalist at the time, and I was like, yeah, I'm going to go save the world and write about all the bad people. I did that for about 2 months, and I realized it was really not for me. And I was 20 and didn't really know what I wanted to do, so I started jumping jobs every year, trying different things to figure out what I liked. While I was doing that, I realized I really missed the quantitative part of my brain. I used to do that a lot in high school, didn't really do it at uni, so I wanted to explore this again. And one of the coolest roles I did while I was figuring that out was being a sports statistician at the Olympics. So essentially this kind of job is basically you're sitting at the edge of the court, you're coding in what the athletes are doing as it's going live. That goes and streamlines straight to the TV feed, and it gives a summary in halftime, et cetera, et cetera. So after I did that, I decided to go back to Loughborough and do something called a postgraduate diploma in economics. So this is like a 1-year crash course equivalent that allows you to convert your degree to economics. There's an equivalent one for statistics and math, I believe, but I decided to do the economics one. Mostly because I wanted to go back to Loughborough and play volleyball, not really because of the degree. So I did that, and when I did that, I was introduced to econometrics. And that was hands down the favorite part of my course. So I asked my professor, what do you do with this? It was super theoretical, x prime x, x prime y. I was like, who cares? How do you apply this? And he said, well, a lot of companies do it to predict consumer demand, so you might want to try an internship in one of them, see if you like it, et cetera, et cetera. So I had an internship at Mediacom and then decided to specialize in econometrics for my master's. So I went to York, did an MSc in economics and econometrics. Probably the most quantitative thing I've ever done in my life. Will I do it again? It was interesting. And then after that, I landed my first job at a consultancy that just does econometrics called Data to Decision, and then moved on to a global media agency called Maxis doing digital attribution modeling and econometric modeling mostly. The really cool thing about working in these kind of companies is that you're not client-side, you don't have access to the data. Half your time is spent trying to convince the client to send you the data because they don't trust you. But then when they do, you do really cool stuff, and then you consult the media planners, etc., to do other cool stuff with the client as well. And then very differently, I recently moved to King about a year ago, and the environment here is completely different to working agency side or consulting side. You have access to literally everything. You can do whatever you want with it, and you can do it much faster because you don't have to run around trying to get people to send you Excel files. Okay, enough about me, more about econometrics. So I was Googling a definition for econometrics to present to you guys because I'm aware that not all of you will know. And I like this one from Investopedia. So essentially, econometrics is a quantitative application of statistical and mathematical models using data to develop theories or test existing hypotheses. And I emphasize this point because it's not about getting the numbers to tell you the story. It's about checking if the story makes sense with the numbers. So you start from the theory part, and you go to the statistics, you say, does this make sense? Is this endogenous? Is this collinear? And then you get to the closest possible answer to reality. I emphasize the closest possible answer because it's a model, it's not the truth. And to quote myself, because this is my presentation, and I can, I find the most fruitful parts of running an econometric model is actually deriving the insights during the modeling process. So as you're testing the different theories, you're seeing what things interact with each other, what things bump each other out, what things amplify because something else has entered the model with it. So that's the the golden part of the whole process. Whereas most business stakeholders, most companies, all they care about is what is my uplift and what is my ROI. But what they don't realize is that after they get the uplift in the ROI, they're going to have to do something about it. Some strategist somewhere is going to have to come up with an idea of how to make that ROI better, but all you've given them is the fact that it was good or it was bad. So the wealth of the process, which is this testing theory, which is an amazing brainstorm essentially, that they can benefit from, is hiding inside of my head. So why do I mention this? It's because when I built the tool, I didn't want it to automate getting to the answer. I wanted to automate all the niggly bits around getting to the answer that was making my life miserable. So what are those niggly bits? What you're looking at here is your typical project process for an econometrics project. So if you go get a consultancy to do it for you, this is the first slide they're going to show you when they're going to try and sell it to you, etc. So the first part is the data collection. You go to your agency, you go in-house, you go to your pricing department, you go to your et cetera department, and you say, can you please send me these data within this time range at this granularity with these dimensions, etc. And then you spend half your life checking that nobody made a human error, sending it back to them, telling them to send you the correct data, and so on and so forth. And then you explore it so that you can come up with primary theories about what you think is driving their business. And then you go back to them, you say, does this drive your business? Because you're the one inside the business and I'm external, so can you please confirm this? And then you validate it, because once you validate it, and if it's wrong, they're gonna make you change your model. So this is like the point of no return. So you go back to them and you say, make sure it's right, because when we get to the end, I'm not changing it. And it's a really fun meeting to have, actually. And then you model, you show them the first inspection, and you get feedback, et cetera, et cetera. So the biggest time-wasting part of the whole process is essentially this part. And the nice thing about doing it in-house and doing it with big data, it all lives in one database. You can literally write SQL queries that can be confirmed by the engineer taking care of that database, whether you've got it in the right granularity, etc. You can get those queries to sit in one script so that if anybody asks you where it is, you can refer them to it, and it's all nice and transparent and there's no problems. So that was the first step of applying it to King. The second step was applying it to the skills that you have in-house. So the typical person in a consultancy would be an Excel user, probably using some sort of eViews or Stata kind of software where it's point and click. If you get lost, there's a manual and there's a help service to refer you to it. Inside King, most people are SQL users in the data science community. They're accessing either R or Python, and we're visualizing most of our stuff on Looker, although I use Shiny. Everybody has a little bit of preferences, right? So like I said, we're SQL users because all our data sits in one place. It's in our data warehouse, and it's accessible pretty much to anyone. Most data scientists will be using their code through Dataland, which is our Jupyter notebooks /Jupyter Hub. Running R or Python on it, mostly to use internal libraries versus external libraries, etc. And then they'll visualize it onto a Looker dashboard or Shiny or whatever you prefer, essentially. Cool, so the solution that I came up with was basically an R-based tool running SQL on GCP, so the actual code sits in an R script, the actual processing sits on GCP, with a Shiny UI front end, that basically lives locally. So you pull the data from all the various sources, you get it all in the smallest possible format because you don't want to overload your R environment. You merge and cross-tabulate it because the LM function prefers that, and then you visualize it in the Shiny dashboard to start your iterative modeling steps. A little bit more about the Shiny dashboard. So when I was thinking about how to make my life easier in the iterative process, I thought about what do I do when I'm modeling and how do I streamline it better? Because one problem I had using other point-and-click software is essentially you check the model, you check the statistics, you then open another window to check the overall health, and you go back to check the actual versus fit. And then, so it's like 4 or 5 clicks that's really disturbing you as you go along. And just to give you a bit of a better idea of what the modeling process involves, so it's essentially, there's two ways of doing an econometric model. One is general to specific modeling. You basically take all your variables, you dump it in the model, and you start taking out all of the insignificant ones one by one. Nobody really does this. It's a very prehistoric kind of type of modeling. Most people, what they do is specific to general modeling. So they say, what is driving my business? So let's say you're a consumer product. The basic thing that's going to drive your business is whether or not you're on a shelf. So the fact that you're in a store or the fact that you've expanded the number of stores that you're in is probably driving your business. What your price is, if you got it right, if you got it wrong, is probably the second factor driving your business. And so on and so forth, depending on what your product is, right? So this is how you start by thinking of the problem of how to model that specific business. So using a king example, you always start with the base, right? The base is your intercept. It has interpretations towards it, but all it is an intercept. So you just shove it in. Then you put in your seasonality. You do this by inspecting what you think seasonality is, and there's various data exploration methods to do that. Then you put your market dynamics. So what are your competitors? What's your share of voice? Are other people doing media at the same time that you are? There are other factors that can fall into this, depending on the industry you're in, but I've just reduced it to 3 or 4. And then you put your media, because that's an incremental driver. If you think about the 4 Ps, it sits in the promotion part of the 4 Ps, which is basically if you turn it off tomorrow, you're not going to die, but you might die slowly if you turn it off for too long. The second thing that I wanted to visualize was all the output, the statistical output. So ideally, I want these things to be in the same window so that my eye can quickly go from one part to the other part without having to change windows. That was the objective. So in econometrics, the way that you assess a model's health is basically using the Gauss-Markov Theorem, which assumes 4 assumptions. First, linearity. X and Y have a linear relationship, quite a strong assumption, but you can test it, right? Strict exogeneity. So you have not used any endogenous variables to explain why. Full rank, which essentially means none of your variables are collinear, so they're all independent of each other, otherwise beta is biased, etc. And then spherical errors. Essentially, your errors are IID. To be able to test these, we use the Ramsey reset test of functional form. If it fails, we log the variable assuming a multiplicative relationship versus a linear one, an additive. Strict exogeneity, essentially don't use an endogenous variable. So it's very simple. You know that something and another thing correlate extremely highly. They're most likely going to drive each other. They're probably driving each other in a circular format. So just don't use that. Use something else that will explain it. Full rank, so finding out if 2 variables are collinear is a bit tricky. You can run a correlation to kind of understand if they have a relationship with each other. But that doesn't give you the full picture. The full picture is given by the various inflation factors. So if it fails, usually they fail together. So you know which 2 are the ones that are causing trouble and you can remove them. Or remove one versus the other. And then for spherical errors, you first start with testing residual normality. So you say, did it pass my Jark-Bara? For serial correlation, you test the Durbin-Watson and Borich-Godfrey, which are very strict tests for serial correlation. If you want like more lenient ones, you can use partial autocorrelation functions and just visualize them and see if there's a problem, or just look at the residual, basically. And for heteroscedasticity, I mean, time series data doesn't usually have that much heteroscedasticity, but just to check, use the Borich-Pagan test. So again, I wanted all of this stuff to sit in one place. So I built the dashboard to literally put them in 4 different widgets in one place. So when I start modeling, sorry, I should probably say. So the dashboard has 3 sections. The model setup, where I call all the data from all the different data points. After I'm done with that, I go into the statistics part, where I can start my iterative modeling process. The first step is this R hands-on table widget, and I'm very proud of this one because it was a really tricky one to integrate. Basically, you start with this empty table that just has the intercept built into it. And then there's a drop-down that you can't see here. You click on it and you select your variable. And after you model, all of this gets populated. So you have to get the table, this little Excel sheet, to speak to the user and then speak to the model at the same time and update itself. I got it to confuse itself quite a lot, so figuring that out was fun. And then, okay, so you've selected your variable, you've clicked Run Model, And then it's going to produce your actual versus fit chart and your residual right next to it, just in the tab. So you can visualize how much of the contribution you've actually explained, where you've explained it, what parts of it you still haven't modeled. After you've done with that, you can look at the statistical health of the variable itself. Was it significant? Was it not? And then you click on the diagnostics tab to see the health of the equation overall. So that's essentially the very static part of it. And I like doing live demos because there's always a risk that something's going to break. Cool. Okay, so first you pick the dimension so you know what granularity you want the model to be. And then you click that first get data the first time you ever run that model for that specific dimension of data. That will run the queries all in the back end, and once it's done, it gives you a little message saying, I have the data. You can import some data locally, just in case you've created some variables that you wanted to add in that doesn't exist in the database at the moment, and as things evolve, that data should live in a database eventually. And then you export it locally so that you don't have to run the queries every time you pick the data, because that's just a waste of money and a waste of time. And then once you've exported it locally, you click on reload previous data, and that will give you the data set that you've saved. And this is the modeling part. So we have some public data here, so I can actually show you guys what it looks like. I'm modeling Candy Crush search term, and I'm going to put in Christmas in there. So yeah, if you have a look at our hands-on table now, it's empty. Run model, and magic. So you get your coefficient, your standard error, your t-stats, p-values, no variance inflation factor yet because I only have one variable in the model. So there's your actual versus fit. So we captured Christmas, not all of it, but some of it. Looks like there's New Year's there as well. And the cool thing about Plotly is that you can zoom in and have a look at things from a closer angle. So if I click run model again, that zooms me out. There's my residual, looks terrible. I really need to work on this model. And then look at the diagnostic tab. Everything has failed. Oh dear. Oh, functional form is correct though. Great. Okay, and then I start with another variable, so that's a TV show. We ran a TV show in the US last year. These ratings are also public, so I can show you them. Yay. And then that captured all of that part of that residual. What does that look like on the actual versus fit? It looks like that. Once I'm done, I want to run a decomp, so I go into the decomposition section. Essentially all this is beta times x, so that you know how much of the contribution of y is coming from x. And you see it on the time series on your right, and you see the total percentage in the table here. So as you're going along, you're looking at, does this make business sense, as well as looking at, does this make statistical sense? And that is essentially it.